So guys, welcome to the current channel, and this video it's a series of all the interview questions that I will be discussing. It has been listed out by Travis79. It is there on his YouTube channel, you can check that out. Okay, so the first question is find the duplicate number. It's a medium level question. This is a good question. I'm sorry, we need to solve this one question here. So the first question states that given an array of nums containing n plus 1 integers, where each integer is between 1 and n inclusive. Okay, and inclusive, that means 1 to 4. Okay, alright, so the first thing to note is that all the integers are in the range of 1 to n. So if we try to get the integer with an index, it will be inside the array only, it will not overflow. Okay, so let's suppose this is the array we have here, and let's say, okay, so it's not all about competitive programming, so it's on different level. During the interview questions here, like, we have been given that we should not modify the array, and it should be in the constant space. So if it was in the competitive programming, we would have done it easily, like we would not worry about space complexity. We would take a different array and we would just copy the set of unique elements into that array and we will return that. But it's not about that in here. We must use the constant space and we must not modify the array. Okay, so what we are going to do is so let's say at the 0th index we got one element, one as an element. Then as it has been given that all the elements will be inside 1 to n. So what is there in the first index? It's 3. Okay, so I got 3 here. Okay, so sorry for bad drawing. It's my first time. Okay. And on the third index we got 2. On the second index we got 4. Okay, and on the fourth index we again got 2. So as you can see, there is a cycle which has been generated. So what we want is to find this cycle. Now how are we going to find this cycle again? Like, we can't just run through the loop. We will run through the loop, but in a different way. Okay. So let's see. Okay, so red color. So what we will do is we will start with the first position, and I think got the red color wrong. Okay, just a second. Okay, so the method we are going to use is normally called hare and tortoise method. Okay, so as we know that hare travels faster than tortoise, so what we will do is we will start from the starting position where both are situated, and what we will do, let's suppose this is my hare, and what we will do is we will say the hare to travel twice as fast as tortoise. Okay, so if starting here, hare will go to here, and which is twice the index. Like at 0 it is 1, at 1 it is 3, and then at 3 it is 2. So we are moving twice faster than tortoise, and we will move tortoise in a single index speed. Okay, now again, why are we doing this? If you think about this, we are doing this because hare moves faster. So if there is a cycle, so there will be a point where hare will meet the tortoise again. So if hare meets the tortoise again, means that's it, we got our intersection point. but it might not be case like there might be a case where if here meets the tortoise again, it might not be the intersection. So we need to confirm that too later. So what we will do is we will, let's take again an example. Now again, if hair moves twice as fast as now, so hair goes here, and tortoise will move here. Okay, so yeah, we got our intersection. But it might be possible that um, this is not the point which is duplicate. So we need to move our tortoise again from the first index to confirm that the element we got is correct. Okay. So now as we notice at the intersection point, we are in the cycle. So here will not move outside the cycle at any time, whatever index we apply. So what we will do is we will say here to go now a single index, like if it is at 2, index 2 and fourth element, then we will tell to go him at the fourth index second element. So now here comes here and tortoise come here. Now again you move here moves forward and the hair comes here and tortoise move here, and we got our intersection. With this intersection which we got is the final intersection, means we confirmed that hare and tortoise meet each other at this point. So this is the element which is repeated twice. Yeah, okay, so how are we going to solve this problem? Okay, so the first, there is always a base condition. Okay, so yeah, base condition is always like if our stock size is equals to 0, we will return 0 because there is no element. Now what we will do is we got our hair to be nums of 0 and we got our tortoise any value. We will start from the first index, like starting point. Now what we can't do like this, like well here is not equal to because it will never it will never run the loop because here is always equals to at the starting point. So what we will need to do is we need to first tell here and to move one position forward, and after that we will start comparing if here is not equals to top. So yeah, now what we want here is we want here to move twice. So what we want is nums of hair. That means whatever the hair value is there, like 1, we want nums of 1 to be 3 and nums of 3 to be 2. That means hair will be 2. Okay, so we got our hair. Then we want our tor to be equals to nums of tor. That means we want one position forward. Okay, so if it is like what is at the first index, it's at 3, so I will move only one index forward, I will not move 2 index forward. Okay. So we got our hare and tortoise means intersection point. In this condition we will get our intersection point. Okay. Now next is let's suppose we intersect at one point, but it might not be the condition, like this is the final intersection and this is the final duplicate we want. This might not be true. So what we want is, now as hair is in the cycle, so it will not move outside the cycle, so we will traverse again. We will say our tortoise to jump to the starting point again, and we will say that while tor is not equals to hair, we will traverse the hair at single index and we will traverse the tor single index, and when they reach again at the intersection point, this is the final intersection, so we will return that. It should be correct. Let's see if there is an error on yeah, okay, alright, and oh yeah, So this was the first problem. And there are 180 problems are total in there. I will try my best to provide 2 problems per day at least. So make sure to subscribe and hit the bell icon, guys. Cheers.